Hey, welcome to my pitch on using Twitter posts to check how offensive somebody else has been. I'm the team. I am Team Vertex. My name is Yuvan Chikka, and here's my email. So the motivation behind it, very briefly, is for companies to check when recruiting the sort of people that their future employees, are going to be online. So the tool, because we've seen quite a few people lose their jobs in the respect in the wider world due to their own tweets and behavior. For example, a woman lost her NASA internship after like saying a bunch of expletives to Hobo Hickam on Twitter. Yes, so I'm developing a tool which would help raise awareness amongst job seekers about the importance of keeping their Twitter accounts civil and clear of any derogatory remarks. It should also allow recruiters to screen applicants much more easily, as they no longer have to filter through hundreds of posts. So the problem statement, I've kind of went over this in the previous slide. It currently takes a while for human to manually check a good bad post. So very simply, mine does that automatically. My program will automatically say, is it a good post, is it a bad post? So I used Kaggle to get this data set and tested a few neural networks locally and found a CNN had the best accuracy, so used that in the Jupyter lab, in the IBM Linux 1 machine. And I used Google for troubleshooting, particularly when I had issues with the SPACY documentation. So the product architecture. So I acquired data from GitHub using read CSV. I then cleaned that data in a few steps, so removing special characters, assigning tokens to words that we don't care about, removing stop words. Yep, and then I make all words undergo lemmatization, so they're all sent to their root forms, and this decreases the size of the dictionary required, making it more efficient and and it also means we can get more insight with less data. And we're using the CNN to predict if the text is offensive, and we're using Keras to make the CNN. So the experiment data and results are as shown. Above, we have a training epoch versus accuracy graph, and this shows over time, over epochs, how effective was the algorithm at classifying. You can see the training accuracy keeps on increasing, so the bias keeps on decreasing, but the validation accuracy stagnates and actually drops slightly after epoch 8, which suggests that it's after epoch 8, the model starts overfitting pretty heavily not heavily, it starts overfitting onto the test data a bit lightly, I'd say. Below is a representation of the labels in the dataset. Obviously, as you can see, this is quite unbalanced, and is part of the reason we see such a high variance. Okay, so my discoveries. So the Twitter API costs $100 a month. It was ridiculous. A few versions of the library Scapy require 4 cores to run, whereas others run a single core. It's very easy to overfit to train data due to the limited dataset. We can use early stopping, and a CNN was actually more effective than an LSTM, which was the most surprising thing out of all my discoveries. And a standard neural network has poor performance in either. So this tool will help people be more consciously careful about their online activities. And this is my conclusion. It contains a few points that I noted down that I've noticed happened when I was running the code. You can read this in your own time. I think that hits 3 minutes.